Hey everyone, we are Group 3, and we worked on the Space Shooter project this semester. Before we go into the details about the development process, I'm going to briefly go over the bare-bone requirements for the project, and as we go through the video, more detailed requirements from our requirement traceability matrix will get crossed out along the way. We were required to make a Space Shooter style of game, make it a mobile application, include a single-player mode, have a login system, have a score system, and have an upgrade and augmentation system. Now that the requirements have been mentioned, let's get into the game. We made the game in the Unity game engine, through which you can build a project to Android devices to have a corresponding Android application package that you can download onto your device to play the game. When you initially start the game, it loads right to a main menu, and from here you can either adjust the game options, log into the system, or hop right into a new game. Let's start with logging in. Upon pressing login, the game calls a function, and it attempts to make a call to an API called Google Play Services, through which it allows the player to sign into the system through a Google account that is associated to their device. And once a player has either signed into the system successfully or unsuccessfully, the function will attempt to authenticate the login status of the user and adjust the main menu accordingly. If you don't have an account hooked up to your mobile device, you can simply add an account or use another one. As seen here, if you do need to add an account, you'll be prompted with this screen where you can enter the relevant information. After a successful login attempt, the main menu will change to having a leaderboard and multiplayer option available to the player. Now let's discuss the leaderboard. For this system, we utilize the Unity asset called Dreamload, through which we can access and upload information through HTTP GET requests. Once a user presses the leaderboard option, a new scene will load and the user will be on the leaderboard scene. Once this scene starts up, it will attempt to refresh the high score data to make sure the data displayed is accurate. Once it fetches the data from the server, it downloads the relevant information about the users and their scores into an array through which the system loops through and displays the information onto the screen. Now let's go back to the main menu. Before I touch up on the multiplayer option, I'm going to allow more discussion on the single-player instance of the game. Once you hit the New Game button on the main menu, the system will load into a new session of the game, starting a new level for the player to play. And from here, I'm going to pass the discussion over to Kate to discuss the single-player version of the game.
When a level is loaded, it triggers a transition to a new scene inside of Unity, containing the level, with all of the enemies, the player, the nav mesh, and any additional scenery. At the beginning of a level starts the movement of the ship along the nav mesh, a predetermined path built by drawn geometry that the Unity nav mesh agent can travel along. The path is drawn as part of the level and a set endpoint is added. The nav mesh agent component of the ship constructs a path to the end of the level, following along the drawn path. The ship itself is held inside an invisible container in which it can move freely, allowing the player to move the ship around as it travels along the nav mesh. The enemy scripts are designed to handle basic functionality, such as basic cyclical movement, such as moving back and forth and rotating. This script also handles multiple types of shooting, including homing shots. If any enemies require more customized movements, complex actions, or animations, the script is able to be extended for such functionality, while retaining all the main features of the script. All interactions between objects, such as enemies attacking the ship and bullets being fired to and from the ship, are handled by Unity's robust collision engine, with sections of the player and enemy scripting handling any and all collisions between the objects.
After the player reaches the end of a level, the upgrade screen is loaded, which displays a variety of options to the player. Upgrades are purchased using the score that the player has earned so far and provide an advantage in the battles to come. The game uses a static script that keeps track of variables such as health, damage, fire speed, and score, so that they can be customized and upgraded with the purchase of these upgrades. With the exception of the health upgrade, each one can only be bought once per level. Once you're finished, the Continue button transitions the player to the next level. Once in game, you can use the upgrades simply by pressing the corresponding button. Here we have the double damage upgrade that starts a timer of 30 seconds and allows you to do extra damage to enemies. In a similar fashion, the fire speed upgrade allows the player to shoot twice as fast. Finally, the bomb upgrade allows the player to shoot a large projectile. Once the timer is up on the bomb, it expands outward, killing everything in its radius.
Now the last feature I want to discuss is the multiplayer system. This feature is implemented through a Unity asset called Photon Unity Networking, which in brief allows players to connect to a server, create a room on that server, and then play through a scene together. First off, a player has to sign into the system to use multiplayer, and then from the main menu, the player can press the multiplayer option, select what level they want to play, and then from there, the Photon Unity Network asset will connect the players to a room on that server, match them up with another player wanting to play on that level. When the two players have connected to the same room, the game will begin, and then the two players can co-op through the level together.